And we're going to be going over lesson 24, and there's two parts, 24.A and 24.B. So 24.A is on the sum of trig functions. So the first thing I'm going to do is draw my reference triangles. Okay, so you should have them drawn as well. You can draw them one time. So I've got my 45, 45, 90. Right, those have it 45, 45 are two of the same angles. I have two of the same sides, and then root 2. If it helps, you can label one of them, but your 45, 45, 90 has two identical angles, so it has two identical sides. Then I've got my 30, 60, and it doesn't matter where you put your short side, but let's say this is 30. So short leg, hypotenuse is double, long leg is root 3. Okay, so here we go. On example 1, what is the cosine of 60 degrees plus the sine of 45 degrees? Now I'm going to put this kind of in a little bubble. This is just, and you can write these on your test. That would not be cheating, okay, draw these on the top because you will be using them a lot. So the cosine of 60 degrees, right, would be, here is 60. So cosine is adjacent over hypotenuse. And then plus sine of 45, doesn't matter which 45 you use, either way it's 1 over root 2. Now the first thing I would need to do here is rationalize the second fraction, right? I can't leave root 2 at the bottom. So this gives me 1/2 plus root 2 over 2. And now notice they already have a common denominator. I don't have to create one. I cannot combine the numerators, so I'm just going to write 1 plus the root of 2 over 2. All right, next one. The tangent of 45 degrees plus 2 times the tangent of 30 degrees. So when I see this, remember I'm reading this as 2 times the tangent of 30. Okay, so let's start with the first one. Tangent of 45 would be opposite over adjacent, so 1 over 1 plus 2 times the tangent of 30. Here's 30 degrees. Opposite over adjacent, so 1 over root 3. Okay, now I'm going to simplify this. This gives me 1 over 1 is just 1, plus I have to rationalize root 3 over root 3. So that gives me 2 times root 3 over root 3. Now these don't cancel, but I do need to create like denominators. So 1 becomes 3 over 3 plus 2 root 3 over 3. And my final answer is, I can't combine my numerators, so I write them together. 3 plus 2 root 3 over 3. I'm writing my final answer as a single fraction. Okay? Next one. I have root 6 times the sine of 30 degrees plus 1 over root 2 times the tangent of 60 degrees. All right, so using my reference triangles, I'm going to rewrite this one. I have root 6 times the sine of 30. If I look up, that's opposite over hypotenuse. Plus, I have 1 over root 2 times the tangent of 60. Tangent of 60, remember, would be opposite over adjacent, so root 3 over 1. Okay, so I'm going to now simplify each. So that gives me root 6 over 2 for this first one, right? There's nothing underneath. Plus root 3 over root 2. And I have to rationalize. Don't worry about like denominators. Always rationalize denominator first. So I'm going to write that. I'm going to write that first. Rationalize denominator first. Which is what I'm doing here. So always do that first. Okay, that's what I did here. This is rationalize. Notice I did that again first here. Then worry about an LCD. So I'm doing the same thing here. Before I try to make a common denominator, I'm rationalizing the denominator first. So this gives me root 6 over 2 plus root 6 over 2. Look how that worked out. Remember, square root of 2 times the square root of 2 is just 2. So my final answer, close to my final answer, is 2 root 6, right? I have 2 of them. I have 1 here and 1 here. So 1 root 6 plus 1 root 6 don't change. I only change radicals when I'm multiplying. So square root of 3 times the square root of 2 is the square root of 6. Okay? So now these cancel, and I'm left with root 6. Okay, so that's pretty much what you're going to see for those problems. Make sure you rationalize denominators, okay? And remember, root 2 times the root of 2 equals 2 because you get the square root of 4, which is 2, okay? So remember that. And now we're going to move on to 24.B, which is the premise of it is review, but you're going to get into more complicated functions. So we're going to go over combining functions. We did cover this in Algebra 2. So here are a couple, here's the notation. I have f plus g of x. This simply means I'm going to add my functions. I have, right, the same would be f minus g of x would mean to subtract functions. Fg, the invisible symbol there, would be to multiply. And then I have something here called f. There's an open circle, g, and that's function composition. That is when you plug one function into the other. That is probably what most people need the review on, okay? So I'm going to turn the page. I'm going to give us two functions to work with. And we're going to do all the different possibilities. So here are my functions. F of x equals x plus 2, and g of x equals x squared plus 3. And we're going to do just a ton of practice with this. So number 1, part A. I'm going to do, let's start with x. I'm going to do f plus g of x. So that simply means that I'm going to add my functions, and I'm going to write them in this order. So function f would be x plus 2 plus function g, which is x squared plus 3. Notice I brought the plus sign down. So now I'm going to combine like terms. I get x plus 2 plus x squared plus 3, and I'll list that answer in proper order. So x squared plus x plus 5. Right? The only like terms were those. All right, number 2, part B. If I had g minus f of x, make sure we write this. I'm going to start with the function of g, which is x squared plus 3, minus the function of f, which is x plus 2. Now, so notice, I carried that sign down. Okay, so when I write this, I'm dropping the parentheses, but it becomes negative x minus 2 because that negative sign affects both. And then I'm going to write this in proper order. So x squared minus x plus 1. Okay. And you probably catch the drift here. So now if I said f of g of x, that means I keep the f on the outside, and I'm going to plug in the function of g, which is x squared plus 3. So this is saying that I'm substituting g into f. So plug into f of x where the x is. So the function of x is x plus 2, but I'm substituting in x squared plus 3, and I end up with x squared plus 5. Okay, let's do that in reverse. So part D, let's do g of f of x. That means I'm keeping g on the outside. I'm going to write the function of f. And so I am plug into g of x where x is. So the function of g is x squared plus 3, but I'm substituting in x plus 2. So that gives me, right, x squared. Remember, this is x plus 2 times x plus 2, but I'm doing it in my head. X squared plus 2x plus another 2x is 4x. 2 times 2 is 4 plus 3. So I get x squared plus 4x plus 7. So that covers most of those. Now let's deal with if these had numbers. So part E. So if I said, what is f of g of 6? So remember, this is saying, what's the function? This is saying we're plugging 6 into each function, then multiply results. Okay, so I'm going to find, it's basically saying find the function of f of 6 times the function of g at 6. So f of 6 would be 6 plus 2 times g at 6 would be 6 squared plus 3. And I'm finding their product. So 8 times 6 squared is 36 plus 3 would be 39. And 8 times 39 is 312. So notice, when I had x, the answers have x. When I'm using a number, my answer is a number. F, oh, I didn't cover divide. Sorry about that. So g divided by f at 3. So this is saying g at 3 divided by f at 3. So g at 3 would be 3 squared plus 3 over f at 3 would be 3 plus 2. So this would give me 12 over 5, which is your answer because I can't simplify 12 over 5. So I should have added that in here. You can also have, and I forgot about f of x would be dividing. So my apologies. All right, let's try one more. Let's try f of g at 3. So the first thing I'm going to do is I'm going to start with the inside. I'm going to find g at 3. So g at 3, I'm going to find this one first. So g of 3 would be 3 squared plus 3, which equals 12. So then I'm going to do f of 12 which would give me 12 plus 2, which equals 14. So I did the inside first, then I replaced that, and then I plugged 12 into the function of f. I'm going to change our functions. So this time h of x equals x squared plus 6. And I'm going to change our function to be pretty complicated. I'm going to do g of x equals the log of x. So this is example 2a. So what is g of f of x? Whoops. Ha! This should be h and g. So h of the log of x, right, because I'm plugging in g. So if I plug in the log of x squared plus 6. All right, so that one's looks pretty crazy. And that is your answer. So, boom. And so that's it. Part B, if I said what's f plus g at 10, so they're wanting me to find f at 10 plus g of 10. Okay, that is what this is saying. So f of 10, I keep writing the wrong letters. It's because I used f and g last time. So h of 10 would be 10 squared plus 6, right? Plus log of 10. Okay. Now, this has an invisible base of 10. So let's start here. 10 squared plus 6 is 106 plus, if you enter this in your calculator, you get 1. So your answer is 107. Okay. And that pretty much covers what you will see. So I should go over what you're going to do in homework. So homework, you're going to skip number 5, 9, 16, 21, 26, 27, 29, and 30. And that is it. Sorry if you couldn't see that. Thank you.